Hello everyone. This video will be for chapter 7 lesson 6, which is the last lesson for this chapter. So basically this chapter is going to be this lesson is going to be a mixture of all the kinds of factorizations which you have learned. So accordingly you could see you have to choose a factoring method. So to start with, let me just take you through these important steps when you have to decide whether factorization is completed or not. So to factor a polynomial completely, you may need to use more than one factoring method. Use the steps below to factor a polynomial completely. So when you're factoring the polynomials, this is what you need to do first. Step 1 is check for a GCF, greatest common factor. We already know how to find the GCF of the polynomials. So step 1 is to check for the greatest common factor, means a common term. Then step number 2 is check for a pattern that fits the difference of two squares or a perfect square trinomial. So if it was a trinomial or if it was a binomial, you could check this too, whether it's a difference of two squares or whether it is a perfect square trinomial. We could check this by this way too, because just in the previous video we discussed about how to find whether a trinomial is a perfect square or whether the binomial is a difference of two squares. So if you have not watched that, do watch that video first, else you will not be able to do this lesson, because as I already told, this lesson is going to be a complete combination of all the lessons which you have learned. So step number 3, to factor x squared plus bx plus c, look for two numbers whose sum is b and whose product is c. So this is already, we have done this in lesson 4. When you want to factorize a trinomial in this form, or if you want to find factorize a trinomial in this form, what you need to do, we have to find the factors of c which would give us the value of b. Here I told you multiply a and c, find the factors and check which factor would give you the value for b. Now step 4 is again checking for common factors. This is what we will be doing mostly when we are finding whether the polynomial is completely factored or not. We are going to check for the common factor, because if there is a common factor, we could still factorize the question. Okay, so these are the methods you need to factor polynomials. For any polynomial, I have told you during the explanation of the previous lessons too, when we are doing the GCF factoring by using GCF. GCF is one of the methods which you could never go wrong. You could use GCF to factor any kind of polynomials, right? So for binomials, you have to look for the difference of two squares. So if they are a difference of two squares, you can factorize them in this way. But you need to be very careful to remember that this needs to be a negative sign, because it says a difference. Now for trinomials, you could use GCF, or as well you could use a perfect square trinomials. So always again remember, when you're working with trinomials, if both of them are positive, your answer needs to be a plus b whole square form. If you're using one negative and one positive, your answer needs to be a minus b whole square form. So this is how it would look if you would factorize this too. Then again here, this method of factorization is how you used to do in the lesson. You'll find the GCF and then factorize them. That's one of another ways to factor trinomials. But for using this method, you know that A and C should be perfect squares, else you cannot do anything. But by finding the GCF, you can never go wrong. You could factorize it in however polynomials they are. Now polynomials of 4 or more terms, we need to factorize them by grouping. So grouping in the sense, you will first group the first two terms and the last two terms, find the GCF of them and then write them as factors. So when you have a polynomial with 4 terms or more, first group them into 2 and then you find the GCF and then factorize it. So let's start with this. You need to say each polynomial is completely factored. If not, you need to factor it. So how do we know whether this is completely factored or not? So here we have 6t squared plus 12. Is there any further way we could simplify this one in the parentheses? Well, this is in the form now, a squared plus b squared, so we cannot do anything for this, right? So what are we going to do? Or can we find out a common GCF or a common term, as said in step number 4? Go for a common factor. Do you think there is a common factor in this? Nothing. That means it's completely factored. So such kind of binomials are completely factored because they cannot be further factorized. Whether we cannot find a common term here, neither can we factorize by using any other method. So that means it's completely factored. So let's look at question number 5. Now first check for any common terms within the parentheses. Are there any other common term which we could use for the factors inside the parentheses? Whether it's an m or anything else. Yes, there are m's. So which means I could rewrite this as 5m, and in parentheses goes m plus 9, right? So we could factorize by using a common factor, because m is a common factor for both the terms, which means we could remove that as a common term with 5. 5 they have already removed, but we still need to factorize it. So this is not a completely factored one, because we could see for a common factor. So if you could see a common factor, remove that factor outside and then rewrite the remaining terms inside the parentheses. So the next one, you will get to it, but then you need a bit of observation and practice. That's all. Now this is in which form? This is in one of the forms of factorization, a square minus b square, right? So which means we could use the difference of two squares to further factorize this. This could be further factorized as p square, and this can still be further factorized as 3 and 3, right? So which means we could again rewrite this in the form of 2p square plus 3 p square minus 3. So you need to keep in mind all the methods of factorization which you have learned until now, and then only you can decide it is still further factorized or not. How about question number 4? Do you think we could still further factorize anything here? Is it in any form of it's already factored, as you could see. They have separated them into two, but then is there any other common term which we could find in these two and in this two? Nothing. So that means it's completely factorized. So it's completely factorized. We cannot do anything more, right? So let's go to question number 5. Now this one, do you think this is completely factored? Can you again factorize anything or find anything common between both of the terms? Anything? There's nothing. So that means it's completely factored, right? Now, how about this one? Do you think this could be further factorized? Now, if you would factorize this further, this is in the form of a trinomial. So we cannot use the perfect square trinomial, because neither 14 is a perfect square, neither 10 is a perfect square number. But then if you would separate them again, you could see that you can find GCF of 2. So if you cannot find a common factor, go to the GCF. What is going to be the GCF of all these terms? It's going to be 2, because 14, 4. Now, if you are not understanding by that, let me show you by this way. GG, these are the factors of 14G. This is the factor of 4G and a factor of 10. So that means the GCF is also going to be 2 here. So which means we could still further factorize this. The common factor for these three terms is not 7, it is 14. So 14, so this is going to be G to the power of 4. This is going to be, what is this going to be? Oops, why did I write 14? 8. We got the GCF as 4, right? So let this 7 be here. Anyhow, we are going to multiply that with the 2. So this is going to be G to the power of 4. And this is going to be 2G plus 5. Now you multiply this 2. So your factorization will be like that. This is how you need to completely factorize. Even if you think that the factorization is there, again, once more check whether we can find the GCF of these factors. If you could find the GCF, you write that and then solve it, just like how you would normally solve a trinomial, and then multiply these two numbers. This would be the perfect factorization, not this one. So you need to first check for any common factors. If there are no common factors, then check for the GCF. These are the two main checkpoints you could do to check whether a question is completely factored or not. So moving to the next one, you have to factorize each polynomial completely. So how do you think you're going to factorize this? Now this is a positive one, it's a plus. So when you want to factorize this, you cannot do anything, only you can find the GCF of 24 and 40. So the GCF of 24 and 40, if you would see, that's going to be an 8. Okay, so this is going to be 3x plus 5. That's all is the factorization for this particular question. Now here it's 5r cubed minus 10r. What is the GCF of these two terms? The GCF of this is going to be 5r, which means that will leave you with r square minus 2. If you're wondering how I got the GCF of 5r, you need to do definitely the prime factorization for this. So if you would do that, that's going to be 5r r, and 10r is going to be 2 multiply 5r. So that means we have a 5 common and a pair of r common. So the GCF of this is going to be 5r. So if you would divide 5r by each, you would get this as the answer. It's easy, but needs a bit of observation, very careful observation. Right, now let's move on to this. What do you think what do you think is the GCF of this these two factors terms going to be? So the GCF of this, if you would do it detailedly as how we did here, the GCF is going to be x square and y. Do it and check, you will get the GCF as x square and y. So that leaves you here with an 3x and plus y. So this is the complete factorization for this. That's all. Find the GCF and factorize it if there are just two terms for an additional binomial. Right now here, now I hope you remember how to factorize this. There is a negative 3. So which means you need to remove first negative 1 as a common number, or what you could do is you could find the GCF of all of them. So the GCF of negative 3, 12 and 12, the three terms. So first let me remove negative 1 from there. So that would leave me with a 3a squared b plus, no, that's going to be a minus. Now these kinds of questions are all explained in the previous videos. Do go check them out if you cannot understand what is being done. So if you have a negative term at the a, this is in the form, right? So we need to remove negative 1 first. Now the GCF of each of this is going to be, let's find that out, 3a squared b, then 12ab, and 12b. Now definitely when you see, you know that it's not a perfectly factored answer, because here we have negative 3, 12, 12, which means we could even still remove negative 3 as a common number. And then we have b, 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 which means we could still remove b. So it's not a perfectly factored expression. So here it's going to be 3a, this is going to be 3, 2, 2, b, a, b. Is going to be 2 multiplied by 2 multiplied by 3. So the GCF is going to be a pair of 3 and a pair of b. So the GCF is 3b. Now leave the 1 like that, multiply, anyhow we are going to multiply that with the factor, the GCF. So divide them, so that would leave you with a square here, and then this is going to be 4a plus, it's going to give us 12b divided by 3 is going to give us a 4, right? Okay, now let me remove this first. It was just for showing you the GCF. Now what we are going to do further is we are going to rewrite this again. Okay, so negative 3b. Now again observe, you could still factorize this because it's a perfect square trinomial. Why is it a perfect square trinomial? This is going to give you an a and this is going to give you a 2. So a square, it's a perfect square trinomial, but do check out if 2 multiplied by a and multiplied by 2 is going to give you a 4a. Does that give you a 4a? Yes. So that means you could still further factorize even after finding the GCF. You can still factorize that into a perfect square trinomial because they said factor each completely. So we have to cut final, like until the last where we could not factorize anymore, we need to keep factorizing that. So this is going to be minus 3b a minus 2 a minus 2, right? So which means I could write this as a minus 2 whole square. So this is now completely factored, not the previous one. Okay, so the next one. Hope you have understood this. Yes, try to do this question by yourself. Definitely you will understand. Pause the video here. Try to do the question 2 times by yourself again and then check. Definitely you will understand what is needed to be done. Okay, the next question says, now this a polynomial. So the first thing first, we are going to factor them into 2 each. Then the GCF, you have to find the GCF. So to find, if you would find the GCF, that would give you a 5t. That means that will leave you with a t square here and a 9 here. Now how about the GCF of this? It's going to be a 3. So that would also leave you with a t squared minus 9. So how do you write this kind of factorization? We did do this kind of factorization, I guess, in lesson 2. So you just need to write it as 5t plus 3 and t squared minus 9. This is all you need to do because both of them are the same. T squared minus 9 is the same. So we take one term from that and one factorization from that and 5t plus 3. So this is a trinomial again. Now you need to check whether you have to completely factorize it. So the GCF, if you would find the GCF, that would give you 2. I think it's a 2. Yes, it's a 2. The GCF is going to be 2. So that will leave you with y squared minus 3y minus 56 divided by 2 is going to give me 28. Now, are you done with this question? Not yet, because you still need to further factorize this. You check what are the factors of 28. Now, this is not a perfect square trinomial, so I cannot do anything here because 28 is not a perfect number, perfect square. So you need to factorize it the other way. Look for the for the factors of 28, which would give me a negative 3. So what are the factors of 28? We have 128, we have 214, and we have 47. So I guess we would work with 47 to get a negative 3, right? So that means it's going to be 4 minus 7 would give me a negative 3, right? So I could rewrite this as y minus 7 and y plus 4. This is completely factorized. So first find the GCF. There are things to do. Yes, you need to look at it very carefully. So there are steps you need to follow, and to before you finish your question, you need to think whether it's completely factored or not. If it is, first find the GCF wherever possible, factorize it, and after factorizing also, if you can still factorize it, once you are finally factorized, check whether we could still factorize it. If you cannot factorize, then that means that's the end of the factorization. So here there's nothing more to factorize. What could you factorize here? Nothing. So just leave it like that because you cannot do anything more. Okay, now for this question, which is number 13, again, we are going to follow the same steps which we did for the previous one. So first, let's find the GCF of this 3. Or you could even simply do the same way which we did, but then this is not in that form. It's not in the form ax squared plus bx plus c. It's not in that form. So which means we need to first remove the GCF, because you could see a everywhere. So let's find the GCF of this first. So the GCF of this is going to be 3. Yeah, it's going to be 3a. How did I find out? You need to do the prime factorization for each term and then find out the GCF. So that means this will give me a 2a square plus 13a plus 15. Now it is in the form ax squared plus bx plus c. So further, now you need to check whether you can still further factorize it. Yes, you can. If you can, then you have to factorize it. If you can't, then you need to leave it as it is. So let's try to factorize this. Now this is not a perfect square trinomial. Neither 2 is a perfect square, neither 15 is a perfect square. So only thing left out is find the GCF. So the GCF of this is going to be no, rather than finding the GCF, we need to multiply. 2 15s are 30, so I'm going to find the factors of 30. I do not know why I said the GCF. We already found the GCF, so for this you need to multiply 2 with 15. So that's going to give you a 30. So the factors of 30 are 130, 215, 310, and 6556. So these are the factor pairs. But all I could work with is with which one? I need to get a positive 13. So I could work with this. So because all of them are positive, so which means I need to add two numbers, not subtract. Now if I would subtract, I would get 15 minus 2 is 13. But here all of them are positive, so definitely I need to get two positive numbers as well. So that means I could rewrite this as a, because it's a, it doesn't say x. So a plus 3 and a plus 10. Now, are we done with the factorization? Not yet, because we need to divide them by 2. So you cannot simplify this. That means the 2 will move simply to beside a, but this could be factorized with this could be simplified with the 2. That means that we leave that with 5 over 1. So finally the factorization is going to be 3a, 2a plus 3, a plus 5. So this is the complete factorization for this question. So moving to question number 14. Now this you could see whether this is a perfect square, difference of perfect square. Can we use that? No, because cube itself is not a perfect number. So we could find the common factor here. So the common factor is x, because both of them have x. So that would leave you with this factorization, because if you cannot further factorize it, you need to find for the common factor. Once you find the common factor, definitely you will come and end up somewhere here like this. Now what does this mean? This is in the form a squared minus, so which means this we could find in the form of x multiplied by x, 3 multiplied by 3, because this is a perfect square, difference of a perfect square. So I could rewrite this as x minus 3 and x plus 3. But then do not forget the common factor which we had already removed before. So this will be the final factorization for this question. So first find the common factor, factorize it, and then check whether it is in any of the forms of the questions which you learned, a square minus b, or is it in any of the trinomial forms which you could factorize. Then if you could further factorize and write it in that form. So for the next question, again here, this minus. So either you could use a difference of perfect squares, or you have to factorize. Now there's not a perfect difference square, because they're not perfect square numbers. So what you're going to do, first find the GCF. So the GCF of 12 and 48 is 12. So that leaves you with an n cube minus 4. Now again, could you factorize this further? No, because this is a cube. We could factorize only for a square, not for cubes. So there is no more factorization for this. That's all is the factorization for question number 15. So keep in mind, if the exponent is a square, just like the previous question which we did here, this is a square because we are finding the difference of perfect squares. But this is not a square, so that means we cannot further factorize this. And as soon as you see this, you know that you need to remove the common factor, or you have to find out the GCF. So if you would do the GCF, you would find this as 3c square. 3c square is going to be the GCF for this. So that means you're going to divide this. So that will leave you with c square plus 8c plus 16. Okay, so now again you could see that in one of the forms of the trinomials which you have studied. So you could first check whether you can use a perfect square trinomial to find out whether you can factorize. I think you can, because here we could divide this as cc. It's a perfect square, and 16 is also a perfect square number because 4 multiplied by 4. But then before you decide on this, check whether if you would multiply 2 with a c and a 4, would that give you the term in between? That's an 8c. Yes, it does. So that means I could rewrite this trinomial in factorized form as c plus 4 and c plus 4. But then c plus 4 also can be written as c plus 4 whole square. So it's a bit different, like how the trinomial looks and finally how the factorization looks. It's like nothing related. But then now if you have practiced enough, if you have good idea of how to factorize, then definitely you will get the factorizations in this form. So the last two questions, question number 17. Now, is there anything we could do here? First of all, that's not a square, it's a cube. We cannot divide that into two. Nothing could be done here. Even if you would factorize it, do you think you can factorize this? That would give you a 6. The factors of 6, which would give you a 4. There are no factors of 6 which will give you a 4. So that means you cannot factorize this. So you have to say it's unfactorable or cannot be factorized. Up to you how you want to describe the answer. Well, this one again is a perfect, I mean, you could use a difference of perfect squares here, but make sure that they are in the perfect square form. Now, well, they are not in the perfect square forms. So what you're going to do, first you need to find the GCF. So the GCF of this is going to be 10w square, which means if I would factorize this, I would get w to the power of 4, and this is going to be 16 because 160 divided by 10w square is going to give you a 16. You want to know how? It's like this. So that means 160 divided by 10 is 16. Similarly, 10w to the power of 6 divided by 10w to the power of 2. 10 gets cancelled, so 6 w to the power of 6 divided by w to the power of 2 means you're going to subtract 6 from 2. So that leaves you with a w to the power of 5. Now again, this is in the form of a perfect difference of perfect squares. So I could further divide this as w square and w square. This also I could divide as 4 multiplied by 4. So I could rewrite this as 10w square, w plus 4, w square plus 4, w square minus 4. Okay, so now you might think that you are done with the factorization. Well, not yet, because look at this part again. again, this is in the form of a difference of perfect square. So which means I can still further divide this as w and 2 and 2. So rewritten the expression, the factorization is going to be w plus 2, w minus 2. That's because they said completely factorize it. So when you want to completely factorize it, this is how you need to do. You need to see every possible situation, whether every term could that be factorized again. Can that be factorized again? Only then, when you cannot factorize anything, then you will write down the last step. So here we have done, in fact, 3 factorizations. First, we found out the GCF and we factorized this. Then again, we further factorized this into a difference of perfect squares. Then once we wrote down, that again became a difference of perfect squares. So again, we had to factorize them. So once you factorize, this is where you will end up at. See, there is no connection between the question as well as the factorization. So you have to be extra careful, but the only thing which could help you is practice, and that's what all I would say. You have to practice. Unless you practice, you will not come across different questions, and unless you come across different questions, you will never learn what to do and what kind of ideas you need to use to solve. So that was all for this chapter. Hopefully you've got all the answers right. So keep practicing, because that's all is going to help you. So till we meet again in the next video, I could advise is keep practicing.